fractions and decimal equivalents. We've already been working with fractions and decimals, and we know that there are two ways to express quantities that are not whole numbers. They're part of a whole. We can use number lines to help us determine that. Think about the number line below. What methods could we use to determine what A, B, and C are? Well, we could start by dividing the number line in half. I think half is about right there. Well, I know that A and B is less than half, and C is greater than half. I could divide it in fours. Again, seeing where A and B fall. Well, 1/4 is the same as 0.25, and 3/4 is the same as 0.75. Now I could estimate where I believe they fall on my number line. I could say that A is about 0.3 and B is about 0.35, and I could say C is about 0.8. They are, let's say 8.5. They are not exact, they are estimations. When you look at number lines, you can see where fractions fall on them. Here is an example, and here's a ruler that we can move around to find equivalent fractions or things that are the same. When I look at 0.5, I can see if I put that next to it, 1/2, 2/4, 3/6, they all are equivalent to 0.5. Let's look at this. Consider the decimal that is greater than 0.5. I'm going to start with 0.8. You can pick any that you choose. And I'm going to find equivalent fractions. Well, if I look down my number line, I can see that 4/5 is the same. I can also see that 8/10 is the same. Right? Now I want to choose something less than 0.8. Let's go ahead and go down to 0.6. I can choose any that I wish, but I'll go with 0.6. If I'm looking at fractions that are equivalent, that could be less than 0.8 or equivalent to 0.6, I could say, well, 3/5 is equivalent to 0.6. If I wanted something greater than 0.8, I could go on over to 0.9. And let's see if I can get my ruler to go straight here. It kind of turned on me a little bit. There we go. Let's get that straightened back out and move it on over. Well, we can see that 0.9, if I look up and down on 0.9, I can see that it is about the same or equivalent to 9/10. Go ahead and play with that a little bit and see what you can do. Here are some more examples. You could see 0.6 is equivalent to 3/5. Less than that would be 2/4, more than would be 5/8. Remember, these are estimations, so they are not exact. Here's another way to look at this. We can look at number lines and determine other fractions that are close to one we are looking at. If we are looking at 4/5, go ahead and move your ruler over to 4/5. And if you need to move it out of the way to help see better, go right ahead. And I could say, okay, I'm looking at 4/5. What is closer, 1/2 or 2/2? I'm going to think, well, maybe 2/2 is a little bit closer than 1/2. But remember, we're estimating, so we're not 100% sure. Then if I go down to 3s, still keeping my ruler on 4/5 so I can see, I would say 2/3 is a little closer than 3/3. Go down again to the 4s. Again, which is closer? I'm saying 3/4 is a little closer. And you can continue on down all the way until the bottom to determine what you think is the closest. Remember, these are estimations, so they're not 100% exact. They are your best estimate, lining up the ruler. What do we think would be the closest to what we need? And then if I needed to find an equivalent decimal, I can go ahead and put it on 4/5, go right up to the decimal and see that that's 0.8. Go ahead and stop the video and give the next two a try. Now when you look at number lines, things to think about when we talk about numbers, where do I even start? Well, the first number tells us where to start. So in this case, 1 is where I would start. 3 tells me how many dashes I count over. So I would go 1, 2, 3. The next number tells me about how much, because it's not exactly 1.3. It's a little bit further. So I would have to go a little bit further over and put a dot in there. So I'm a little bit in here. And that would be 1.33. Here's a way we could practice. We can go ahead and practice on this number line. If I needed to find 0.75, well, it doesn't have a whole number, so I know to start at 0. I'm going to start at 0. I'm going to count over 7. 1, 2, 3, 4, 5, 6, 7. And then 5 tells me I go halfway. So I'm about right there. If I wanted to look at 1.66, I would start at 1, count over 6. 1, 2, 3, 4, 5, 6. And 6 is more than halfway, so just go a little bit further. Remember, they're estimations, so they're not 100% exact. You can continue to play with the number line, and I have another one here for you as well. Now, let's write some of these. Well, we know to put things on a number line, we need to change them to decimals. That is the easiest way to do this. So if I'm looking at the first one, 1 1/4, well, that equals 1, excuse me here. Go ahead and lock that down for us so it doesn't keep moving. It's 1.25. And then I have 1.75. 2/3 is about 0.66 repeating, and 1/8 is about 0.125. Now I can go ahead and place them on my number line, starting at the beginning. If I start with 1, that tells me where to start. So I'm going to start at 1. I'm going to move over 2 dashes and go halfway between in order to put my number line. So I'm about right in here for A. For 1.75, start at 1, count over 7 dashes, 1, 2, 3, 4, 5, 6, 7, and go halfway between because it is a 5, and there would be B. For 0.66, it doesn't have a whole number, so I start at 0, and I count over 6 spaces, and I go a little bit more than halfway, so here is C. D, 2.3, start at 2, count over 3 spaces, and I don't go any further. It's right there on the dash for D. And then 0.125, that's a little harder. I'm going to start at 0 still, count over 1, and go 0.2 over. That 5 really does not play in when I'm putting it on my number line. So there we can go ahead and see that. If you want to go ahead and give the bottom one a try, please stop the video and do so now. Just change E to be 4/5 on your paper. Now, how do we understand? Do we really understand what we're doing? Well, when I look at 5 here, if I'm trying to find A, I know it's more than 1. So I'm going to start out with 1 point because that's where I start. Then, is it more than halfway or less than halfway? I'm estimating it's just a little bit more than halfway. So I'd say that's 1.6. Now to change that to a mixed number, I want to write it exactly as I say it. That is 1 6/10. So I'm going to write it as 1 6/10 because 0.6 is really 6/10. Now look at B. Starting at 4, so I know that's my whole number. Is it more than halfway or less than halfway? That's the first thing I ask myself. Well, this is very much less than halfway. So I'm going to say it's approximately 0.1. So 4.1, I'm going to say, or 4 1/10. That's how I could write it as a mixed number. And for C, again, where did I start? I'm between 7 and 8, so my whole number is 7. And I'm going to say I'm almost to 8 on this one. So I'm going to say it's about 0.8, 0.85, 0.9, anywhere in there would be fine. And that would be 7 8/10. Exactly as you say it, you would write it as a mixed number. Again, let's consider 3 1/3. Which of the following decimals is closest? Well, we know 3 has to be there because that's the whole number. Now, if I put my ruler on 1/3, where is it closer to? Is it closer to 0.3 or 0.4? Well, when we look at it, we can see, and here's another view, that it's a little bit closer to 0.3 than 0.4. So I'm going to say it's 0.3. And the way that we can explain that is by estimating where it falls on the number lines. Here's another example, 81 5/6. Well, again, 81 is my whole number. My decimal then is if I look at 5/6, what is it closer to? Is it closer to 0.8 or 0.9? Here's another look at it. If I look up, I can tell that it is a little bit closer to 0.8, right? By looking on the number line, we can estimate where it is closest. Now use our skills to put things in order. Again, estimating what is the decimal. Well, the decimal for 5, 6, we can go ahead and estimate what we think it is, or we could go ahead and calculate that out because we already do know how to change fractions to decimals, and that can help us with our estimation. If you're not sure though, go ahead, look back at your rulers, and let's see, where does 5, 6 lay? So I'm going to come back to right about here, go over to 5, 6 and say, well, it's about 0.85 if I look up here at the top. So let's go back over to that, to 0.85, let's say. We already have 0.7. 2/5, well, that's about 0.4. That one's pretty easy. And then the other fraction I have is 3 1/3. Well, we've been talking a lot about thirds, and we know that's 0.33 repeating. Now remember, if I can't see them, line up my decimals. 0.85, 0.7, 0.4, 3.1, 0.5, 3.33, 3.6, extend out a little bit here, and 5.2. Now I can start seeing what is the smallest one that I have. Well, I can see here that I have some without a whole number, 0.85, 0.7, 0.4, 0.5, don't have a whole number. Which is the smallest of them? Well, I can see that the smallest is 0.4, so that's going to be 2/5. The next smallest is 0.5, which is 1/2. Then 0.7, which is there for me, I don't even have to calculate, and 0.85, which is 5, 6. Now look at the ones with whole numbers. I have 3.1, 3.33, 3.6, and 5.2. Well, we can see 3.1 will be the next smallest. Then 3.33, which is really 3 1/3, 3.6, and 5.2. Go ahead and give it a try. Now let's see how much we really understand. If somebody was having a homework assignment, would you say that 2/3 is really equal to 0.9? If you're not sure, go ahead and get out your ruler and estimate on your number line chart or change to a decimal. Well, 2/3 is really 0.66. So we would say, no, this was not correct. This is incorrect. Is 3 7/10 really 3.7? Well, I read 3.7 as 3 7/10. So yes, that is correct. 1/5 or 2.0. Well, is 1/4 even a whole? No, so that would have to be incorrect. And 2 3/4 is equal to 2.75. Well, again, I read that as 2 3/4 can be changed to 2 75 hundredths, which is the same way as 2.75 could also be read. So yes, that would be correct. Go ahead and give your homework a try and let me know if you have any questions.